Right, I'm going to question number 2 from paper 3. It's very important to do all these questions because you need to be prepared for doing all this at the end of the year, and it comes really quickly. So this type of compound is hydrated water soluble. I'm sorry, I can't pronounce that name, this thing here. Water soluble mineral with relative formula mass of 453.2. The formula of this mineral compound can be represented by MXH2O, where M represents all the ions present. So this table 4 shows the composition by mass of everything in that compound. An analysis has found that the mineral contains ions like NH4 plus ions, Al3 plus ions, and SO4 2 minus ions. Calculate the empirical formula of this mineral and the value of X in this compound. Okay? Right, describe the test and with the results, including ionic equations that would confirm identities of the ions present. So the first thing we did the calculation of empirical formula. So we put all the letters here, okay, and then you got the values that they're given us, which is 3.09, 6.18, 5.96, 14.616, and 70.61. Divide by the MRs, so molar mass here, or atomic masses, and that will give you values. And the values all these values has to be divided by the smallest one. That gives you a ratio 1 to 28 to 1 to 2 to 20. So the empirical formula of your mineral contains N, H28, Al, S2, and O20. So the next page is the same question. They want to ask you different the tests with their results, including ionic equations that would confirm identities ions present. So all I did is I took the different tests you have to do. Test for ammonium ion, you have to know that by learning, the different tests. Add some dilute sodium hydroxide solution to unknown substance in a test tube and gently heat the mixture. This gives off an NH3 gas, which can be tested with a damp red litmus paper, which will then turn blue if NH4 plus ions is present. Okay, so the equation for that is NH4 plus OH minus gives you NH3 gas plus water. The test for sulfate ions is SO4. Add a little dilute hydrochloric acid, followed by a BaCl2. If white precipitate of barium ions formed, sulfate ions are present. So you got the equation here, which is Ba2 plus SO4 2 minus gives you barium sulfate, which is a white precipitate. Test for aluminium 3 plus. Add dilute sodium hydroxide solution dropwise to the solution metal ion. A precipitate will be observed and will redissolve in excess sodium hydroxide. Aluminium 3 plus is present. So the equations for that Al3 plus 3OH gives you your solid. If you carry on adding in excess, you end up with this OH added, and you end up with this formula, for example. You could keep going from OH minus 4 minus, you add another one, you get AlOH 5 minus, etc. Okay?